All right, Calc BC, welcome. This is the 5 for the day 4. I just printed it out. You guys want to, again, prepare yourselves before you start the timer and before you look at the questions to have your 5 pages with your APID and initials ready to go, and your timer ready to go as well, where the screen doesn't turn off the auto lock in the settings. Don't print out the page. Use whatever device you're going to use the test on tomorrow to look at these questions so you can mimic the actual exam tomorrow. I printed out for the sake of being able to show you the questions under the DocCam for this video, but I am not writing on that worksheet. I am going to treat it like it is on the screen and take the test as if you would be taking the test, as if I were taking the test. So I don't know how many questions there are on the test when it's given to me, so I leave the pages labeled blank until the test starts. And here we go. 15 minutes, go. I'm giving the test. I count how many sections. 1, 2, 3, 4, 5. Okay, I have 5 pages. That means 1 page per problem. And I'll set that up now. On the actual test, it'll be A, B, C, D, E, F, and so on. But you don't know how many until you're given the test, so you want to take the time to parcel out your paper. It's either 1 problem per page or 2 problems per page and cut it in half if there's more than 5 sections. I imagine the first test will have more, the first question will have more than 5 questions because it's the 25-minute page. All right, so let's see what we got. This time we only have a graph and not a table. So the function f is differentiable on this interval, -2 to 12. 3 line segments. That is a typo. I see 1, 2, 3. I see 4 line segments. So, and f of 4 is 14. All right, BC1. On what open intervals is the graph both decreasing and concave down? Wait a second. Are we given f or f prime? This is pretty tough. Well, it doesn't say in the directions. It says f is differentiable. Oh my gosh. This is a bad question. So I'm going to assume what I see. I'm going to assume this is f prime shown. And I'm going to yeah, because otherwise there is no concavity, right? So this is the f prime graph, and we know an initial condition of the f graph. I think that's the way to go. All right. So when is f? F is decreasing and concave down on, well, that's when f prime is negative and decreasing, right? So when f prime is negative, the original function is decreasing, and when f prime is decreasing, the original function is concave down. We're really good at this stuff. We've done this a lot. So I see the function is negative and decreasing here and here. All right. I think you can put brackets if you want. I like using the parentheses. So it's decreasing and concave down when the function, when f prime is negative and decreasing. That's from 1 to 7 union 9 to 12. And you could probably just write and when x is between 9 and 12. You could use your inequality notation and all that stuff too. What is the reason? Because f prime is negative and decreasing on these intervals, or on this interval. I think this is technically one interval because I unionized it. If you said and, you'd say intervals. I don't think you're going to get a mistake with your grammar here. BC2, let g of x equal the product f of x times f prime of x. Find g prime of 4. Okay, so I have to take the derivative of this. Product rule. Fine, cool. G prime of x. I got this. Derivative of the first times the second. Plus, I usually don't do it that way. I usually say it differently. So I gotta get the flow going. First times the derivative of the second. Okay, first times the derivative of the second. plus the second times the derivative of the first. That's how I usually do it. But it was going to work out if I remembered what to do in that other order because I'm adding, I can move it around. All right, so I need g prime of 4. G prime of 4. I bet you're getting a point just for writing this, to be honest. And that's why knowing the formulas and writing down your thinking and not just going straight to the answer can give you points. So it's going to be f of 4 times f double prime of 4 plus f prime of 4 times f prime of 4. I'm going to hashtag DNS it. F of 4 is given, it's 14. F double prime of 4 is the slope of the slope at 4. So I have the slope equation at 4. And the slope of that line is rise over run down 2 over 3, negative 2/3. All right. F prime of 4 is the y coordinate of the f prime graph at 4, which is negative 2. So it's negative 2 times negative 2. So I'll just square it, and I'm just going to box that and move on, right? DNS, if your scientific calculator can do it, you don't have to. BC3. Find the average value. Average value. I know what that is. There's a ring to it. Average value equals integral over interval. I'm just going to write that down so I know. But I want the average value of f double prime of x over negative 2 to 12. Okay, so that's going to be the integral from negative 2 to 12 of f double prime of x dx over 12 minus negative 2. Okay, so this is going to be the area under the curve. Okay, so that's going to be just a bunch of little triangular areas. No big deal. 1/2 base times height. 1/2 base times height. So it's going to be 1/2. Well, I'll factor out that 1/2, and I'm just going to do base times height plus base times height plus base times height because it's all triangles. So base times height, base 1, 2, 3, height 1, 2, 3, 4. 3 times 4, that's the first triangle. It was positive, it was above the x-axis. Plus, wait a second. No, I'm doing it wrong. Okay, so this is going to equal f prime of x. See, it's not the area under the f double prime graph. So it's the area under the f double prime graph, and I don't have that. You know what I mean? So I'm going to actually evaluate this. This is going to be the antiderivative of f double prime, which is f prime, evaluated from 12 to negative 2 over 14. So now that's going to be f prime of 12 minus f prime of negative 2 over 14. F prime of 12 is negative 2 minus f prime of negative 2, which is 4 over 14. I have another idea of how to do this because since I know the f prime graph, I can actually probably graph the f double prime graph and see if that gives me the same answer. This ends up being negative 6 over 14. Do I get the same answer? So what is the slope of the first segment? It's down 4 over 3. Down 4 over 3. So it's negative 4/3 for the first segment here. And then from that's negative 2 to 1. And then from 1 to 7, the slope is negative 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, negative 2/3. So this is negative 2/3 here. And then from 7 to 9, the slope is a positive 1, 2, 3, 4 over 2. It's a positive 2. And then from 9 to 12, I'm worried here. Am I going to run out of time? Down 2 over 3. So this area is going to be, so this is 3 times negative 4/3 plus 6 times negative 2/3 plus 2 times 2 plus 3 times, I'm actually taking the area under the f double prime graph here. And so 3 times negative 2/3. Okay, 3's cancel there. 3's cancel here, so I get negative 4 plus negative 4 plus 4 Minus 2. Negative 6. Okay, this is good. I'm done. Moving on. BC4. Find d squared w over dt squared. Okay, so that's going to be the derivative with respect to t of dw dt, which is the derivative with respect to t of what dw dt is, which is 9 minus w squared. You got to remember chain rule here. And so that's going to equal 0 minus 2w times dw dt. So they're just checking to see if you know your chain rule. So that's going to be negative 2 times what w is, which is 9. Wait a second. Oh, it's in terms of w. Okay, so that's fine. So I can have negative 2w and then times dw dt, which is 9 minus w squared. Okay, good. Done, I think. Yeah, derivative 9 minus 2w, chain rule. Got it. BC5. Right, but don't evaluate an integral expression in terms of w and t that gives the arc length. Okay, so arc length L is that formula a to b of the square root of 1 plus f prime of t, or f prime of x squared dx. All right. Hold on. Got to limit distractions. Got to be doing these tests without distractions. Okay. Oh, sorry. Hopefully my screen was showing the last problem well enough. In case you didn't see it right. Well, here's the original f decreasing concave down. You got your answer there. BC2 DNS product rule. BC3, two different ways to get the answer. I took the antiderivative evaluate at the endpoints and I got negative 6 over 14. And I would have gotten the same answer if I actually graphed the derivative of the derivative using slopes and found the area under the curve, the signed area under the curve. I still got the same numerator, negative 6, divided by the interval. And then BC4 was taking the derivative of the derivative. Don't forget chain rule, and it's actually a really easy problem. And then now we're here to this arc length one where that's a new formula, but it just work with it. We can do this. So it says write but do not evaluate. So this is going to equal the integral. It gives us the bounds. It's 1 to 3. Square root 1 plus. Okay. So we need the derivative, and we have it. This is, I think, easier than we think. See, w is a function of t. It tells you that here. And so it's a dt because w is some function of t, so you need the t's to match up. Even though it says w here, you don't say dw. Wow. I made mistakes. I did a problem 2 different ways. I have 3 more minutes to go and double check my work. Arc length is the same thing as distance. I think we're good here. Take a look at the solutions in the Dropbox. Let's just double check everything looks right here. BC1, on what intervals is the graph decreasing and concave down? That's when f prime is negative and decreasing. That's from 1 to 7 and 9 to 12. BC2, find the derivative of this product. First times root of second plus the second times root of the first at 4. F of 4 given. F double prime of 4 is the derivative of the derivative, or the slope of the tangent line of the f prime graph, which using rise over run gives you negative 2/3. F prime of negative 4 is given in the graph. That's negative 2 squared. BC3 was the tougher one, but remember, fundamental theorem, the integral of f double prime is f prime, evaluate the endpoints, and we know the endpoints from the graph. That, I think, is easier than finding the graph of f double prime. I ended up doing that just to double check my work. If you can do a problem more than one way, that's what you use with your extra time if you have it, as well as what I'm doing now, which is I would make sure I copy down the question right onto my paper, right? That's usually a big source of error. You've noticed that in your homework. BC4, the derivative, the second derivative is the derivative of the derivative. The derivative 9 is 0, so negative 2w times the derivative of w. It wants it in terms of w, so the 2w is fine, but you have to change dw dt with what it is given to be. Perfect. This is doable. I'm going to turn this off. I want you guys to email me if you need help. I'm here until 2:30 today, and I'll be available maybe for emails later on in the day as well. And then office hours, emergency office hours in the morning tomorrow before our test around 8 o'clock, 8:30. I think I'll do 8:30 to 10:30 tomorrow. Okay. Hope you guys are doing well, and you're practicing as you're gonna play tomorrow. The nerves will be there. The heart will be racing. You need to practice that now. All right. I believe in you guys. Take care.